So now we will move to our third example, and let's take a look at it here. So in this example, this is actually a mess which I have created, but this is generally what I see that a lot of people write this kind of a code. What we are doing here is we have a main function, and here we are using Gorilla Mux, but it doesn't matter whether you use Mux or Ginionic or Echo or Fiber, whatever. Important point which I want to highlight here is how we are defining all these methods and what is the behavior which we are seeing inside these functions. Let's get inside the get all customers and see what we are doing here. So the first thing we are doing is we're creating a client and then a list of customers, an empty list of customers, which will be populated from the database. And we are making a query to the database. Once we have the data, we have the rows from the database, then we are iterating over them and storing all those customers one by one into this customer slice. Once we are done with that, then we encode them into JSON and then we print it in the response. So by doing this, we are writing the JSON in the response. In case of any error, then we are writing the internal server error in the response. So this is what we are trying to send here. Now think of writing a unit test for this functionality. And if we see here, we are getting the database client. So it could fail because my database connection is not available. It could fail if there is some problem on the database side, or it could fail because we are not able to encode the JSON in the right format. So there are various reasons because of which this code can fail. So there are too many responsibilities which are assigned to one single block. And we cannot run this code in isolation. What I mean by this is because we are getting a DB client and then we have this hard-coded dependency of the database inside this function. So there are too many challenges here. Although we can write a unit test for it, but it will not provide us the right kind of a feedback. So for that, we need to structure our code in the proper way. And then we have the sample app, which is again the same code was structured in different layers. So we can go here and see, but before that, let's look at how different responsibilities are assigned to different components. So when we are structuring our code, we need to define the right responsibilities. So if we talk about route, so they will be responsible for receiving the request and sending the response, anything else. And for any heavy lifting, they are going to delegate that work to the service layer, to the next layer. So next will be the service layer. So, and the service acts as a collaborator. So service talks to various different components. It can talk to another service. It will talk to the repository to get the data from the database. It will also be helping us to convert the domain objects into the DTO objects. So all the collaboration work, it is done inside the service. And the next is the repository. So the repository will be helping us in interacting with the outside world. So anything which is external, anything which we are querying will be done through the repository component. Domain component, it will contain the core business functionality. And DTO is the one which carries the data between the processes. So all the data which is coming from the caller to the route, that will be received in a DTO. So same from the route to the service, the data will be transferred to the DTO. And then your service is now aware about the domain. Then when you are talking to your domain side, you need to convert these DTOs to the domain objects. So all that transformation, it is again done inside the service layer. So let's look at the code again and see how we have structured. So we have this main, and inside main we have defined our route definitions, and then all these routes, they are defined inside routes. So we have those get all customers and save new customer, and all the heavy lifting. So we are delegating the get all customer request to the service layer. So here the service layer, if we get inside the service layer, so service is a struct, and then we are initializing a global variable for customer service inside it, and then we are doing the rest of the work. Then we are calling the domain repository, and we are asking the database to find all the customers for us. And once we have all those customers, we are converting those customers into the customer response, because this is what we want to send back. And then inside the DTO, we have the customer request and customer response, something similar inside the domain. So there's no business logic at the moment, but if there is any, yeah, then it will be attached to the customer struct as a receiver method. Domain also contains the repository. So this component will be responsible only for the database side and nothing else. So this will query the external world, it will bring the data, pass it on to the server side. And inside the data source, we have the database configuration. So now my application is structured, and let's see how to write the unit tests for routes. So we'll start with writing a unit test for get all customers, and let's create a new test file. So we'll write our test, and let's say it should return all customers with status code okay, which is 200. Now to write a unit test for a route, what we need to do here is we need to define a HTTP request first. So let's say new request. The method is the get method. Next is the URL, which is customers. And because it is get, so there is no body, so we can just pass on nil to it and store this inside a variable. So this is a request, and it might return an error, but while we are writing unit test, we can just skip this error, because this is a test, and then we know that this is not going to return an error in unit test. So we have this new request, and now we need to make a call to this request. But before that, for our test setup, we need to initialize the router here. So we need to define a new router, and we need to load this endpoint to get all customers. So we have the router, and the handler is attached to that router. And now we need to start the server. So to start the server, we say r.serve HTTP. So this takes a response writer, and it takes a request. So we have the request, but we don't have the response writer. So let's create a response writer for the test thing. And that is done by HTTP test.new recorder. So this is a recorder, and what it does here basically is, so what happens is when we are trying to encode all the customers, so what we are doing internally is we are writing all these customers to the response writer, which is W. And through our test, when we create a new recorder, it provides a recorder. So what it does is this basically provides us a HTTP response writer for our test. So let's get inside the recorder and see what it does. So it returns a new, it returns an initialized response recorder. So whenever we are trying to write something on the response, this is the recorder which records all of that information. And then it becomes easier for us to assert on this recorder. So let's pass the recorder to it. and the request to it. And now we will say if recorder dot code is not equals to http dot status OK, then in this case my test should fail. Test fail should be 200 OK. And now let's run this test. So if we run this test, yeah, so my test is passing. This is pretty cool. And now here what I'm going to do is I'm going to fmt.println, and I want to see what is the response which is coming from the recorder. So to see that, we can say recorder.body, because it is again a response writer. So it has received the response, and we can take the body, we can print that body, and now we can run it. So once we run it, we can see this data coming out, and this data is coming from the database. Although we have written a unit test, but my call is going to the database. So now let's do one thing. Let's stop my database server, and here I say docker stop MySQL. And now let's rerun this test again. So now when we run this, we can see my test failing, and my test is failing because my database is not available. And this is the problem which we get if we have any external dependencies. And this is also one of the reasons why we should always write unit tests in isolation. My tests should not be dependent on anything, right? Any external factor, because if my tests are dependent on any external factor, then these things will happen, right? And your tests are going to fail because of various reasons. Now we need to fix this problem, right? So what we want is we don't want our request to go to database, so we need to isolate that. Now let's come back to our test here and see what we are doing here, right? So we have the service, right? So we have the service, and it has this get all customers. So my service is defined as a service struct, right? And we are defining the customer service as a global variable, and then we are attaching this as a receiver function. And if we see inside this, this is the direct reference to this variable. That means when I start my project, right, this variable get initialized. It creates a copy of the customer service, and which is available globally. Now what we want to do here is we want to isolate that, right? But I want, when I run my get all customers, my request should go to customer service, but my customer service should not make a call to the database. That is one thing. Second thing is what is more important here, right? What do we want to test? So what we want to test here is that when I call get all customers, my customer service should be able to return some data. Now it doesn't matter if the database is not available. That is none of the concern of the route, right? So it works on these two conditions. So whether you will get the data or you will not get the data. So the responsibility of the route is only, okay, I have delegated this request to some external call, whether I'll get the data or I'll get the error. That is those two things. So what I want to test here is, when I have some data or some error, am I able to write the response in the right way? Am I able to send the response in the right way to the user or to the caller? And that is what we need to test here. We don't need to test whether I'm able to make a call to the database or not. So that means this call, it doesn't matter. This particular call which we are making to the service layer, it doesn't matter. So even if we are able to fake this call, right, we should be able to run this route, this controller function. Okay. So now to make this work, what we need to do is think of this route as a higher order component, right? And this customer service as a low level component. So your customer service, this is your route is dependent on the customer service. So without the customer service, we won't be able to run this route. So we need this customer service, but the dependency is very hard coded, right? So this is a concrete implementation. We have created an instance of the service struct. So what we want is we want this to be loosely coupled, right? So for that, what we are going to do is we are going to define an interface so that my dependency from my route to my service is loosely coupled, and that the relation should be defined through an interface, through abstraction, right? Not through the concrete implementation. So what we are doing is we are defining a concrete implementation here. And that is what we need to change here. So what we are going to do here is we are going to define an interface. And I say it customer service interface. Right? And I copy this from here. And the moment I do this, you can see all these green things coming here. This means that this service is now implementing the customer service interface. So if we click here, and it will take me here, and this is the downside. And then it has another function, a method. Once we do with this is all fine, right? So we are not changing anything. We just have introduced an interface. Now, what an interface means in Go. So Go has a very nice way. I would say it is better than Java, and it uses duck typing, and you don't need to enforce, or you don't need to decorate your struct to tell this struct that you need to implement this service, right? So because Go supports Go duck typing, so if it looks like duck, it quacks like duck, then it is a duck. So my service, I say any struct which has these two receiver methods is implementing customer service interface. It is just like that. So once you define an interface, and any component which has these two methods will start implementing customer service interface. Now we made this change, and now what I want to run this test again, right? So let's switch on the database again, so that even if it is wrong to go to the database, I'm still getting some feedback, right? So what I want at the end of this exercise, we should get rid of this thing. My call should not go to database, and that is what we want to do here. So now we have defined this customer service interface, and now let's define a helper function which says new customer service. And this returns the service, which is the concrete implementation. So I think it would be good if we can change this to a different name. Default, we say default service. Okay. And I'm going to comment this out. We don't need this. Right. So I have just renamed my default service to give it a better name because it was just a service, or default customer service. I think that would be even better. Default customer service, right? So I have a customer service interface and I have a default customer service. Although you should never name your interface with this, because it is again a specification. It is something what it does. So this is not denoting the technical meaning, right? So it is telling me, yes, this is an interface, but what is the intent of customer service as an interface? Why we are defining it? It should be just be customer service, but we are just keeping it so that you understand that this is an interface and this is the default customer service which has implemented this interface. And what we want from here is it should return default customer service. That's it. So this is one thing which we have changed, although there is no change in functionality. And another change we are going to do here is none of these functions here, get all customers and save new, they are not the receiver. So let's create a receiver. Let's attach them to a customer handler. So I'll define a customer handler here. Right? And I define handler and customer handler to it. Right? A small change. Now, this customer handler, this will have a dependency of the service. So I say service, and this service will be of type customer service interface. And now, instead of calling it with this variable, I can ask my customer handler, okay, give me the handle for the customer service. So I can say h dot service dot get all customers. And we can do the same thing here. H dot service dot save customer. That's it, right? So this is loose coupling. This is again an interface. So my customer handler, it is now dependent on that interface, right? Not on the concrete implementation. So if we go here, this is not defined. So now what we need to do here is we also need to define a handler here, customer handler, and service will be new customer service. And I say handler dot get all customers. So this is a small change which we have done in our tests. So it will still be going to the database. Let's see here. Here also I need to create that handler, customer handler, and service will be new customer service. And let's call them through handler. Right. So I have created a handler now, and these are the receiver functions, receiver methods of the handler, right? And now this handler is having a loosely coupled dependency. The service is of type customer service interface, but I can provide a hard-coded, a hard dependency, right? A concrete dependency to it. So when I say new customer service, this returns me the default customer service, which is implementing customer service interface, and that makes it loosely coupled, right? Okay, so far so good. And now when I run my test, it will still run. It is still going to the database, right? Not a problem here. But by doing these small changes, we are able to change the dependency, right? So now if we see this customer handler again, and we see this get all customers. So what it is doing here, it is not dependent on h.service, which is handler.service, and which is a loose implementation. It is dependent on the interface, not on the concrete implementation. So through my test, when I'm writing my test, I can change, I can provide a different behavior to this get all customers. And by doing that, I will be able to isolate my unit test, right? And if I'm able to isolate my unit test, that means it will run without any external dependency. And in that way, it will be faster and it will provide better feedback. It will not be dependent, so it will not fail because of any third-party issues. So is it fine, or do you have any questions? Anybody has any questions?
When you initially said at the beginning of the training that we are going to make our code more testable, now everything makes sense, what you actually meant, not just breaking the code down to single responsibility principle, then for those specific components, just writing the test code for that particular thing, and then following that, how to, as you said, make your code, make some of the how to say, some of the functions and our calls more flexible,
Right.
and how to so yeah, it's pretty good. Yeah, so far so good.
Cool. Thanks. So so this is clear, so I can go ahead now. Now so through here, so now when we say here in our test, when we see the service, right, and here we are again passing the same new customer service to it. Now let's do one thing, because Go is duck typing, and what I want here is I want to define a new struct, which is fake customer service, right? I'm defining a fake customer service, and I define those two functions. Same those two functions, but now inside my test. So this is service and fake customer service. Cool. Now this should return a slice of DTO.customer response, which will be like this, some ID. It could be anything, right? My test is not dependent on the kind of data which I am receiving. I just want some data and some fake name and some fake city and zip code and date of birth, some date of birth, and the second parameter of this is nil. But this is still not following, not implementing my interface, right? So I also need to define this here. And I say fake customer service and this guy, and this should return this. Let's leave it for now, right? So now I have a fake customer service here, and we can see these green signs here, and this means my fake customer service. If I click here, it will take me to the customer service interface, which means my fake customer service is implementing customer service interface. Now I can click here and I can see I have two implementations of my customer service interface. I have a default customer service and I have a fake customer service, which is being used by the test. Cool. So now what I also want a new fake customer service, and we return fake customer service from here. That's it. Now, instead of passing this service dot new customer service, if I pass new fake customer service, my test is going to work, and this time it is returning me this fake data which is coming from my fake service. Now at this particular moment, even if I stop my database, my test will still run because it is not dependent on any external factor, right? So this is how you make those loosely coupled components. Yeah, Harry, you want to say something?
Oh, no. I just, no. Everything makes sense so far. Yeah.
Right. So now think of this route and this customer service. Think of this route as a high level component. This is a high level component, which is dependent on a low level component, right? Customer service interface. This is a low level component, but they are dependent on the abstractions. Customer service interface, this is an abstraction, right? This is not a concrete implementation. So if we go here and read about dependency inversion principle, what it says is high level modules should not depend on low level modules. Both should depend on abstractions, right? And this is what we have seen. This is what we have built. And abstractions should not depend on the details. The details should depend on the abstractions. So all your abstractions, even if you have abstraction, then they can again, yeah, it should never be dependent on the details. So this is what the dependency inversion principle is all about. And what we have done here is like we have injected a dependency to my handler. And once we inject this dependency to the handler, a loosely coupled dependency, which is abstracted dependency, then at any point of time, I will be able to change the implementation of it. And this is what provides us, like this is a better design, because at any point of time I can change the dependency. Another example of it is your database drivers, right? So let's see it here. If I say sql.db, right? And I go here. So this is a struct, but this is implementing a closure interface. So again, so what they have done here is whether you use PostgreSQL or you use MySQL or any database in the world, right? Your SQL statements are going to look like same. Right? This is not going to change, right? So what is going to change every time is the data source. How you are defining your data source, right? So when I say SQL.open, I'm telling him that my driver is MySQL and my data source URL is this. I can say PostgreSQL, the data source URL will be different, but in both the cases, it will find out the driver is defined here. Now, through this, it takes that driver and it connects this client through that driver. So if you go to open, it returns a Debian error. So at any point of time, you can change your database. You can just switch on to Postgres, just change the URL here, your code works fine. And that is again, same dependency inversion principle that plays there, right? So it is everywhere. It makes your code loosely coupled, and highly cohesive as well, right? So there's a cohesion here. When I have defined a handler, all the handlers, whether it is get all customers or save all customers, they are just handlers, right? What they are doing is just the work of the handler, the responsibilities of the handler, and nothing else, right? So let's also revisit another principle, which is single responsibility. And now this says a class should have only one reason to change. And what does this means is, in terms of Go, we don't have classes, right? We have structs. So when we are talking about class, so what it means is my handler, it should change because of only of those responsibilities for which we write the handler. So the handler is responsible for taking the request and sending the response back to the customer, or back to the caller, basically, right? So if I'm going to change this component, it should be because I want to change this, or I want to change the some logic which is related to the handler. And same with the service layer, and same with the repository. So if I'm going to change my repository, right, it should be only because I want to make a change in the database layer, not because of the customer service, or not because of my domain object. So I should not be able to change that. So one component, one responsibility. But one responsibility doesn't mean one single responsibility. Like it is a shared responsibility which this component is having. Suppose there's a PDF manager, right? So you have a component called PDF manager. Now that PDF manager, it is responsible for writing and reading and doing some PDF stuff. It will never do that Excel stuff, right? And that is what is meant by a single responsibility principle. Write one component, make it responsible for one thing. If you're going to change that component, it should be because of that reason, because of which that component came into existence, and not because of any other thing. So once you are able to do that, you will start writing code which is loosely coupled and highly cohesive. It will become like a Lego block, right? So something like we have this repository, or something like we have this customer service, right? So I can inject this customer service into some other functionality, and it will still work, right? Any questions till now?
I was a bit slightly confused with high level and low level, and then I understood that how high level modules actually depend on low level module,
Right.
but shouldn't depend on the implementation. So
Right.
and then you created interfaces and you decouple
Right.
the definition from the implementation, and that made sense.
Yeah. So
This is not just, I mean, to be honest, sorry, I'm interrupting. This is not just testing. This is like good principles, good coding principles. Yeah.
Right.
Yeah.
So once you start developing in this way, writing unit tests will be very easy. Like, it will be fun for you. You will really want to do it every day.
Agree.
What I meant with concrete implementation is the way we were doing it earlier. So this particular component, this is dependent on the service. And here, this is again, when I say get all customers, this is again not the implementation. This is again that abstraction. When I say get all customers and I go inside this, it will take me to that abstraction. The concrete implementation will get attached to it once this handler receives the new thing. So the thing which we are doing from here. So once you provide that new customer the concrete implementation to that, then this thing will come into being. Otherwise, this is just a loosely coupled thing. There's no implementation here. Okay. So do you guys want to take a break?
Yes, 5 to 7 minute break would be okay. Just gonna get a cup of tea.
Sure. So let's grab it and then let's meet in 5 minutes.
Yeah. Okay.
Is it fine? Okay. Hey, should we start?
Yes, I'm here. I don't know about others, but I'm here. Yeah.
Yeah, we can start.
Okay, Gagan. Does anybody have any questions? So is it making sense which I'm talking about?
I'm pretty new to this Golang, and from past 1 month, I'm learning Golang. So these
Okay,
things are new for me. I'm learning as much as possible.
okay, cool. Cool. So what I'll do is I'll just recap of whatever changes we have done, right? Let's start from here. Well, I think it will be a good way to just do a diff of the changes, right? So this is what we had earlier. This is what we had earlier, get all customers. And now it is all same. So if we see inside these functions, right, inside this method, the only change we have made is the handle to the customer service. So earlier it was a concrete implementation, the customer service, this was the implementation, but now this is the interface. This is loose coupling, right? Same we have done here and no other change. And inside the customer service, so we have introduced a new customer service interface. And again, if we see, it is again same, right? No other change apart from this function.
Yeah.
And even this function is also not required. You can just directly do the same thing, default customer service inside your main class. I can just write default customer service here. I can instantiate that. But doing it through a function, it makes it more readable. Like what we are doing, we are trying to instantiate a new customer service. In terms of reading your code, yeah, it helps. Otherwise, apart from that, nothing else. So tomorrow you might have some more dependencies where something like still my database is still not my database is not a dependency to the customer service, which ideally it should be. So now if the database is also dependent on customer service, so what I can do is I can pass that thing from here inside this. But what we try to do here is we try to inject the dependency from outside, and this is what we call wiring, right? So what we have done is we have wired the new customer service with the customer handler. Okay, this is the term which we use, wiring, and I think there's also a project called wire go wire. I think this is again done by Google, and this is a compile time dependency injection for Go, which does something similar which we are doing. Okay, nothing different, but it just generates all those dependency and it stores it into a file. It generates a class. This is also a very nice tool. If you want, then you can also use this. Okay. Okay, so now we have this fake dependency here. And now what I wanted to show you by this is you can create your fake, or you can create your stub or mock. It doesn't matter, right? So what matters is whether are we able to inject the dependency, are we able to inject, or are we able to change that dependency at runtime whenever we want to do it. Now building fakes is good, but then it has its own limitation. Now, for example, this is only the first test which we have written, right? So now I want to write another test, and I say duplicate it, and test should return status code 500, right? So if things are good, it is writing and it is returning 200. But in case if we have received any error, then we are printing status internal server error, right? So now what we have to do here, everything will remain same, but what I want from my customer service, get all customers method. Now this time it should return me an error, right? So what I want is it should return like this, nil and errors dot new and whatever, some fake error. See, this is what I want. But now if I do this, what will happen? My only one implementation will work, right? Either this can work or this can work, or I have to put some condition or something, or I have to make another fake customer service 2, which returns something like this, right? And that is where the mocks are going to help us. So when you create a mock, mocks also provide you the stubbing or faking functionality. Although mock doesn't means that it is just going to mock it. In terms of unit testing, mock means when you are testing the expectation. We'll see it going ahead. But the mocking framework, it helps you in changing your expectations at runtime, and that is what we are going to see now. But to make this test work, let's do this thing. Okay, I have commented this out and I'm sending error. And now what I should expect here is the status unprocessable entity. No, sorry, 500 internal server error. Right, should be 500. This is what we are returning. And now let's run this test. So I'm running only this specific one test, right? So if I run both of the tests, now what will happen? The first one will fail and second one will pass, right? Some fake error, because in this case also it is returning the same value, and that is the problem. So I can just make one of my tests work and other one will not, or I have to make two fake implementation, which is again a lot of work to do basically, right? So what we want, we don't want to use this fake customer service. Instead of fake customer service, we will use mocks. So I'm going to remove this, right? And let's comment it out. Just put a X here and it will not run. And yeah, so I think I need to just comment it out, everything here. Okay. Now what I want to do here is I want to provide a mock here. Now how to provide a mock, how to generate a mock. The first thing, if you want to generate a mock, you need to have an interface, and only an interface. If you have defined an interface, then only you can generate a mock class. Now, what is a mock basically? A mock is a kind of a dummy implementation. A mock provides you a dummy implementation. So this is something which we are doing inside the mock, inside our functionality. And my mock will do nothing, but it will just tell me, okay, you call this, what is that which you want to return? Okay, we have to define that expectation. So the first thing we are going to do is to generate a mock for this customer service interface. And to do that in Golang, you need to have mock project, Golang mock, right? And this provides you two things. One thing is that you need to have this mockgen library. This is the command. So once you do a go install, this will be installed in your machine. And second thing is you need to add this other dependency. You just need to do this. Go get GitHub Golang mock. So when your project is having this mock dependency and you have this mockgen tool, you can use both of them to generate it, right? So let's see how to do that. Let's add it here, and yeah, I can just switch it off. Let's make it small so that it is visible on the screen. And let's also get rid of this. So I already have this thing here in my machine, but just to show you, I can just do it again. So what we'll do is we'll install the mockchain. Okay. And then if I say which mockchain, it shows it is installed here, home, Ashish, Go, and mockchain. Right. So this is where it gets installed inside my Go. And then what we want is this Go functionality, this as a dependency inside my project. So because my unit test workshop, my go.mod is at the root, I'm going to do this there. And this is added this dependency as go mock. So I have this dependency now, and I have the mockchain tool. Now what I need to do here is to generate the mock class for customer service interface, right? And to do that is to write the command mockchain, and then you pass the source, like where is the source file. So the source file is inside sample app, and what is the path here? Service and customer service. Service and customer service.go. So once you say mockchain and you tell that this is the source file, and it will see how many interfaces are defined inside this, and it will generate the source code for it. So we can see it here. It has generated the source code and it has printed it on the screen. It is we have still not saved it to a file, right? And we say the packages mock service, and then it is doing a lot of things here, right? And what it does most importantly is it gives you this thing. It gives you new mock customer service interface, right? So this is the implementation. So now what I want this to store it in a file inside mocks service and customer service.go. I hope this is visible. So I'm just putting it out here. Okay. So once I do this thing, what it will do is it will create a mocks folder, a service folder in customer service.go. Let's come back here and see that mock here. So this is that mock file which was generated. And now the default package name is mock service. Okay, if you want, you can change it. You can just pass on another parameter to it and say package equals to service. And then it will have the package service, but yeah, that's fine. We will just use the mock service so that it differentiates that this is the mock service package and this is service package. So far so good. And now instead of this new fake customer service, what we want is to inject the mock here. So to create a mock, you use mock dot go mock dot new controller. Okay. Now inside this controller, you pass the test reporter, which is the T, which we are receiving from here. Right. And now let's create a variable for this. So we have the controller here, and now let's use our mock service, new custom service, new mock customer service interface, and we pass the controller to it. Right. And we say mock service. So by this, we have created a mock service instance. And now what I want to say here is, oh, not this, no, mock service dot. I expect that when we call get all customers, then it should return me whatever it returns is DTO dot customer response, right? Same thing which we were returning from fake ID, and then fake name, city, and zip code and date of birth. That's what, right? And now instead of this fake service, I am injecting mock service here. And this is good. Like, so we have created a mock, we generated the file, and then this is how we created those hooks. And this is, we have defined our expectation. So when the mock service dot get all customers will be called, it should always return this thing. So this is something which we are doing from the fake service earlier, right? So when it was called, so we were returning this. So instead of writing a complete class, you can just do it through a small one line implementation. Right? And now let's run our test. Okay, I'm doing something wrong, and that is because I've returned my get all customers. It returns two values, right? So let's see here. It returns where is it? Here. So it returns a customer response and it returns an error. But from here, I'm just returning this, and the second parameter will be null, right? So I think let's make it a little bit readable, and let's extract it out into a variable and say what fake customers, right? So when my get all customers is called, it will return fake customers and nil, like those two values. And now let's run this, and this is passed. So now it is returning those, and my test is passing this fake value. And now because we have mocks, I should be able to write my another test, right? So let's remove this guy and copy paste the initial structure from here and put it here. Now, instead of fake customers, we don't need fake customers this time, right? Because we know we don't have that. Right? So we have nil. And instead of nil, we have errors.new. So this is the failure case. So when I call get all customers, the database is down or not available or something happened. And in that case, it is returning some error. Some fake error from the service layer. It doesn't matter, whatever is the message. And now I inject the mock service here. Right. So let's get rid of this. And now I run this. Oh, sorry, X. I need to remove the X. So both of my tests. So it should return all customers with status code OK, and with the 500 one. So both of them are passing. I can remove this body. We don't have this here. So this is how you write tests for using mocks, basically. So any questions on mocking?
Yeah, a bit new concept for me, so I'm just absorbing.
Okay. So think it in terms of the same fake functionality, the way we have introduced the fake customer service. And if you go inside this, where is it? Here. So if you go inside this and see, it is again, what it does is basically it provides you a fake implementation, and it also provides a recorder. Now what that recorder does, it once the call goes to your function, right, the fake get all customer function, it marked it as just the call was received inside the get all customers, right? It records it for the testing framework. And basically this expectation, this is also an assertion. So here also we are on the mock, you can put an assertion of the mock. So when you do this, you are doing two things. You are putting an assertion, and you are also defining the behavior of get all customers. Like when this thing is called, what should it return, right? And now let's suppose because of some reason my call is not going inside get all customers, right? So if I say if true equals to false, and only then it should go here, right? And it's define the variable for all customers, which is a dto.customer response and error, so that it get compiled. This thing, right? So we know that this will never be true, right? So it will not be going inside this. Now when I run my test, now what will happen, right? So here it says missing calls to mock service dot mock service get all customers. So aborting test due to missing calls, although it was expecting that the call will go inside this, right? My get all customers will be called, but because of this condition, it is not going inside this. Okay, and this is what puts the assertion here. There, this thing comes into being, this expect thing. So it is expecting, if I have defined a mock, and that means I'm expecting that this will be called at least once, right?
Mm.
So if the call is not going there, then it will say fail. So there are conditions, right? And you want to test a particular condition, that whether I'm able to interact with that external service or external call. So you can also do things like this. And
Yeah,
in that
a lot
way,
of syntactic sugar as well, in just
right, right. A lot
good.
of. So all the mocking frameworks, whether they are in Java or in Scala, or everybody has a similar kind of a syntax, a little bit here and there because of the difference in language, but they are not very much opinionated. The opinion is coming from the earlier days, the way people have defined, but more or less all of them work in the similar fashion. So
Understood. Do you, for testing, if you need like a dummy data, so
right.
do you use a library like a Faker or something? Like I come from Ruby background, and we have a Faker gem. And
Right, a lot of fixtures.
yeah, it just, you mention the type of data you want,
Right,
and you get a lot of like almost relevant dummy data, just
right, right.
yeah. I mean, we were talking about testing, so I don't know. This is not relevant. I'm just just asking. Have you ever
No.
come across? Yeah. Do
Yeah,
you
yeah.
use that?
Yes. So what you call them is canned response, right? Canned response. All
Yes.
those
Yes.
are like fixtures and canned response, and then yeah, they help. So suppose you are working for an airlines. I'm taking this example because I have a lot of airline domain in the back. So you're working for an airline where you want to look for a request from suppose Delhi to London. Okay, I want to see how many flights are available. Now, when we receive this information, there's a lot of data and various combinations, various flight segments. The flight will first go from Delhi to Mumbai and then from Mumbai to London. That will be one segment, and it could have 5 segments. It could have various combinations, pricing. So the data is actually data is the one which drives the functionality in those cases. The behavior is all dependent on various different kinds of data. So in that case, what you do is you save all those canned responses. And a lot of time what happens is the airlines test systems, they are not working, or it is really expensive to call all those systems every time. So what you do is you store all that data inside your uh, machine, inside your test cases, and then you use them as fixtures or your canned responses, and then you can develop using
Yeah.
those.
So you build your canned data, sort of from
Right.
production data, take the personal
Right.
information out, and yeah.
Right.
I mean, this faker gem I'm talking about. I'm sure there's also an npm, and there's a library. It's language agnostic, and what you do is just you ask for those request for those constants, for example, first names, and you get like
Right.
bundle
Right.
of
right.
first names, and
Right.
okay,
Right.
give me some addresses, and it does that. So
Right.
now that we were talking about testing, and I'm just is it like I don't know if I'm sure there is something for Go as well. People use that, even if in Faker, I'm sure it
Right.
kind of
Right. Yeah, I haven't explored that, but I'm
okay.
sure they will be, because people keep on writing yeah, all the frameworks and all the library. You see, the Go has so many things. Generally, most of the things are not required. Like even for unit testing, you see it is inbuilt. You don't need any external dependency, but then again, you have so many other frameworks, Testify and so many others. But the core thing about learning Go is the more time you spend with Go, then you start understanding, yes, you don't need a lot of external libraries. You can still work with the standard library. It has everything inbuilt. The only thing is, yeah, frameworks, they provide you a little bit of help, but it is not like Java, not like Spring Boot, where your framework is driving your complete development, right? So in Go, it is not like that. Your standard library is super powerful. Just with the core language, you don't even need Gorilla Marks, or you don't need Gengonic, or for that matter, anything. Right? A lot of people work with the in-house grown libraries. And the more you use libraries, you are making your executable much bigger. Right? So the size of it will be a very fat binary which you will be generating, and yeah, that is what is not required. And you work with small things. It has a very small memory footprint, the binary which is generated by Go, and that makes it ideal for running it on Docker or Kubernetes or for microservices environment. And yeah.
Yeah. No, that's what I like about Go. The simplistic nature, keep things simple.
Yes.
Very small, syntax.
Right.
And very kind of, when I say small, I mean it's like
small, and
fit for purpose.
Right.
Sort of.
It is fit for purpose. It is very, very simple, like very simple.
Yeah.
That is the beauty of Go.
Agree.
So cool. So this is what I wanted to share with you guys. A few more things, I suppose. I have a list of recommended books, and these two books. There are a few more, but these two books, what I understand is Test-Driven Development by Kent Beck, and this is what has shaped how people do unit testing and test-driven development. He is again considered as a father of test-driven development. And then this book from Growing Object-Oriented Software Guided by Test from Steve Freeman and Nat Price. This is again a very beautiful book. Talks a lot about test-driven development, clean coding practices, agile, how you do. It also talks about doing DevOps kind of a stuff, building a walking skeleton. So it is really nice book. They are again in Java, but it doesn't matter. You will get a lot of knowledge. And then this thing from Martin Fowler, refactoring. How do you refactor? And what are those code smells? What are those signs when you start to refactor? And then this article again from Steve Freeman and Nat Price, mock rules, not object. This is again also very important, and to understand the mocking mindset, like what needs to be mocked, because mocking is a very powerful tool if used correctly. But you can just abuse it, and you can write bad tests, which will not which will work, like your tests will work, but it will not give you the right feedback. So listening to your tests is very important, and understanding like why we are mocking, what we are mocking, what we can do with mocking on the interface level, loose coupling, and all those things. So he has defined it very beautifully, and I think you can find this article on internet, mock roles and not objects. So you guys can go through it. And then two more books on domain-driven design, especially if you are working on the microservices. You want to build microservices, then this is again the backbone of how you design your microservice. This talks a lot about coupling and cohesion, right? And this book from Rebecca Werfs, this is again, it talks about roles, responsibilities, and collaborations, the thing which we discussed about, like what should be the role of the route, or role of different components in the system. And this thing, what I personally think is, this book is very rare to find, object design, but if you find it somewhere, then I would say read it. And this is, I think, what has grown into domain driven design, right? So the ideas are same, but the domain driven design has evolved into a different thing now. Yeah, this is these are the 6 books which I think if you guys read, then they are really going to help you.
Can I ask you something just related? Okay, so this going for a Go job, and I'm sure everyone who's looking for an entry level or junior to kind of like, yeah, entry level developer job in Go. If you are hiring someone tomorrow, for your team, what are the must-haves, the essential level of testing knowledge that you, what do you expect from that individual if you are hiring tomorrow? And what are you looking for?
Okay, so what we look for is, and what I generally look for is that about his object-oriented concepts, right? And whether it is Go or non-Go, if you are able clearly in terms of object-oriented 4 principles, like abstraction, polymorphism, inheritance, and all. So if you understand them clearly, you will be able to write code which is cohesive and loosely coupled. And that is what I look for. Like, I don't look for, even if you don't have the knowledge how to write unit tests, that thing again can be taught. But everything is driven by the basic design. What I have seen people, they write objects or structs, and then they don't attach receiver functions to it, and then they do all those things in simple functions. So why are you not attaching those functions, those responsibilities? Because that is what object-oriented programming says. So you should have objects, and then you should attach functions to it, and those functions will manage your objects, right? Once you start doing this, your functionality is attached to those objects. Things will become easier to manage. That is what I look for. At a junior level, this is the expectation, because everybody who is coming from college, so they all go through this. Like, everybody has read a lot about object-oriented programming. They have developed a lot of softwares in the colleges. So that is what I ask them. That is what the basic is.
No, that's important, because the encapsulation bit, that's basic. You have to be, and also having working knowledge of interfaces and specific to Go. How
Right.
this is implemented in Go,
Right.
inheritance and all that things, and the good bits of OOPS, object oriented.
So although Go is not an object-oriented programming language, yeah, but it has those object-oriented parts, and which makes it really nice to handle, which makes it really nice to structure your code to make it more manageable, as we have seen in these exercises.
Mm-hmm. No, yeah, there's so much to absorb in today's training, specifically the later half.
Right.
Yeah.
I hope it will make sense. I'll be looking for your feedback. You guys can just fill it. Give me some feedback where I can improve. Or if you like something, yeah, you can tell me.
Yeah, I've got the link.
Yeah. Yeah, so that's all from my side. And if you guys have any questions, if you don't have now, then yeah, you can just drop me an email. You have our email address, and then I'll get back to you on that. And if you have any questions right now, yeah, you can just ask.
Okay, so I just wanted to ask, like in real world scenario, like if I join a team, a project which has been going on in Go, the project has already reached, say, some time has already been spent by the people on development, and now I join them, and so so now I start writing, unit tests. So the
Right.
project is not in a shape that what I saw today, that a lot of refactoring needs to be done
Right.
before the code is, made unit testable.
Right.
So what is your advice? I mean, what should be done in that scenario? Where should I start?
So one thing is the first thing is what we need to do is to bring all those people into the same page. If the complete team is facing that pain, and they understand that writing unit test is really important, then you can go to the Scrum Master, create a tech debt item, start pulling some of the item, keep the campground cleaner than you found it, right? So this is again a rule. So if you are working on any code and you find that yeah, something can be improved, and that is again the Kaizen philosophy, the Japanese philosophy. If you can just improve 1% every day, you in a very short duration, you will see a lot of improvements coming in your life, right? The same applies to the code. Just whenever you're working on a story, if you think that something can be improved, yeah, just do it. Leave that campground cleaner than you found it. That's the Boy Scout rule.
Yeah, but in that kind of situation, it will be like, doing up or redoing on a very big scale.
Yeah, it
Right?
will be, but then yeah, though, so the current application which is live and which is on production and which is running, which is generating revenue, it cannot be stopped. So the best suitable way to do that is just keep on doing it in small intervals, small steps. Keep on changing the behavior. You don't need to go big bang. So even in today's exercise, if you see, I had not made any big bang changes. You make a small change, test your assumptions, and then make another change, test your assumptions, and then just keep on going like this. Don't do any big change which might affect several files, because if you're going to do that, then the code will not be in your control. Right? A lot of functionality will be
Yeah,
broken.
one change might impact a lot of things,
Right.
and
Right.
I need to be running and the team has to be doing a lot of regression with
Right.
every change, whatever I do. Or
Cool. So any more questions from anyone? Okay, so I also have a course in Udemy, and which is running good. It is a bestseller, and I have this coupon code, which is a discount coupon. So if anybody is interested in that course, yeah, you can just go and buy it. You will get some discount through this. That is based on REST APIs and hexagonal architecture. And the link to this repository, I'll share the link to this repository, and I'll also add that database file here, right? The Docker Compose file with the initialized data in that database. So you guys can use it as an exercise. I'll not be posting the solution to the exercises so that it remains an exercise for you, right? You guys can then just do it again. You can just keep on refactoring, and yeah, that's good. Then anybody has anything to say, or we can
Just going through that. Sorry, yeah, just going through that Udemy page, and yeah. So you're using SQLX, so keeping things
right,
simple and
right.
not using big ORM. So yeah, okay, good. Looks good. The testing bit in that training, is that something similar to what we did today? Because I see state-based test.
Right. So, but those tests are based on the project which we are building there.
Sure.
I borrowed some of the code here. It also has a similar customers API, and it also has account functionality. So it is a banking application, right? And but it has a little different kind of information and more about the project and the components which we are building there, how to test those components. But yes, from the unit testing perspective, yes, this is we are also generating the mocks there, testing APIs, and we are doing the similar things in the similar way. The only difference is here we started with the code which was not well written, but there, because we are using hexagonal architecture, so from the start we are building the code in the way which is easily testable. So that is the difference. Here we have improved the code, and there the code was already improved from the beginning. So the code was already testable at all the places. So that is the thing.
I do like one thing that you have a very well-rounded knowledge and about like best practices, and some people when they do most of the training that I've come across, they're very piecemeal. They just do one thing and then they move on. They don't give you the big picture. Because they don't have that kind of experience, they're not able to explain. Now you're talking about hexagonal architecture here, so I don't know how many trainings go through that, or dependency inversion principle that we saw today, and
Right.
so yeah, so I'll be definitely checking this out.
Thank you.
And I found you very tech savvy and hands-on. I mean, that was awesome seeing somebody code, I mean, so fast and very nicely structured manner. So that's amazing. I mean, that really shows the amount of knowledge you have and what goes beyond. This is a session of few hours. I mean, I really appreciate the way you explain the things.
Thank you, Suruchi.
Yeah, and the content is also very good, so that's a good thing. Is it possible for you to share the slides? I want.
Yeah, sure. I'll share the slides,
okay.
and I'll share it through your email. So I have your email
Okay,
IDs, so I'll share that, and I'll also see if I can also share this recording. Right?
Sure.
Although this is like half-cooked recording we have, but that's fine. I think we have all that mocking thing covered here, right? That thing was recorded, and I think that will help.
Yeah, that's the part that I would definitely like to revisit, because the first half, fortunately, was very easy to follow. Was easy to code type with you. So yeah, but when we hit the API, that's where that's why I said, oh, whoa, wait back, just look at it, what Ashish is doing, and then so yeah, so that'd be definitely good to. I mean, I'm looking forward to actually just go through that once again.
Okay, Sure. So I'll share that.
Thank you. Thank you.
Thank you. Thank you, everyone. And yeah, and see you at some other time then.
Definitely, definitely. Yeah, love the workshop today. Thanks again. We'll look forward to any further future offerings that you may have.
Sure.
So yeah, I'll personally be in close touch. So definitely.
Sure.
Okay, thanks.
Thank you.
Thanks once again. Cheers. Have a good one.
Thank you. Thanks a
Bye.
lot. Bye-bye.
Bye-bye. Bye.